All right, Friday I talked about gravity, and more specifically how the mathematical model for the height of something thrown up and pulled back to the earth by the attraction of the mass of the object and the mass of the earth. Now, how fast an object falls depends on how long it has been falling. It does not depend on how massive the object is. It only depends on uh, how much time. So, and just so you understand, if I was dropping my pen versus, say, the calculator, which is more massive than the pen, um, it seems like the more massive thing would be pulled harder, and it is pulled harder by the earth. But because it's more massive, it takes a stronger pull to speed it up. Just like accelerating a bicycle versus accelerating a car, the car being more massive takes more force to accelerate it than the bicycle. So, because those balance out, the how fast something speeds up is pretty constant, and the it the acceleration, how much speed the object picks up as it falls, depends on only on how long it's been falling, and so there is an equation for that, either in the metric or the um, English system, either in meters and seconds or in feet and seconds. And this is so common that it shows up so often in the mathematics courses and in physics courses and a lot of courses. The number here for each of these, I want you to know, to memorize. It's like knowing how to add or subtract as far as I'm concerned. So I'm going to show you what's going on here. So in meters and seconds, an object will pick up will travel at 9.8 meters per second faster than it did each second it falls, up to a point. Okay, now I want to explain how this works. So I'm going to make a little table here, and then I'm going to do it again for the feet per second. So I'm going to say the time is 0, 1, 2, 3, and how fast it's falling, the velocity. I'm going to round this off to approximately 10 for the moment. And so if I'm just dropping an object, it's going 0 at the beginning. After 1 second, it would be going 9.8, but I'm rounding it to 10. After 2 seconds, it'd be going 20. After 3, it'd be going 30, because each second it picks up 10 meters per second. Each second it picks up 10 meters per second of speed. So after t seconds, it's going to be 10t. 3 times 10, 2 times 10, 1 times 10, 0 times 10, t times 10. And the distance that it has fallen will be 0 from where I drop it. And after 1 second, well, its speed isn't 10 the whole time. It starts at 0 and it gets up to 10. Now, if it was going 10 all the time, it would have gone 10 meters. But if it starts at 0 and gets to 10, its average speed is about 5, and so it would have gotten 5 meters. After 2 seconds, well, in 2 seconds, it went from 0 to 20, so its average speed is 10, But 10 for 2 seconds, 1, 2, makes it move 2 times 0 plus 20 divided by 2, 10. 2 times 10 is 20 meters. And after 3 seconds, it goes from 0 to 30, which is an average of 15 for 3 seconds. So 15 times 3 is 45 meters. After t seconds, it goes from 0 to 10t, which is an average of 5t times t, and so the distance is 5t squared. Okay, well, that's because I rounded off to 10. It's really 9.8, and so instead of half of 10, it's half of 9.8. So the height will be 4.9 t squared. That's the distance it's fallen. So now if I count up as positive instead of down as positive, it would be negative 4.9 t squared. So half of the acceleration, this is the acceleration due to gravity at the surface of the Earth, is 9.8. So the height of this object after t seconds is negative 4.9 t squared. In the feet and seconds, it accelerates 32 feet per second speed every second. It goes 32 feet per second faster every second. So if I make the table again with t and v and d and 0, 1, 2, 3, it's going to be going 0, 32, 64, and 96. And after t, it's going to be going 32t. The distance will be 0. 0 plus 32 divided by 2. Average is 16 times 1 is 16. 0 to 64, average 32 times 2 is 64. 0 to 96, average is 48 times 3 is 144. Average of 0 and 32t is 16t times t, 16t squared. So the distance it falls is 16t squared. If we flip it so its height is positive going up, then the height after some time, if it was just dropped, is negative 16t squared. So if you ever see negative 16 t squared, you know that the height is being measured in feet and time in seconds. If you ever see negative 4.9 t squared, you know the height is measured in meters and time is in seconds. The negative 4.9 and the negative 16 t squareds are something I feel you should recognize as the height as affected by gravity. This is half of the acceleration due to gravity in metric system, and half the acceleration due to gravity in the English system. All right, that's something I talked about on Friday.